CompSci Intro. We're going to look at color today. So I've got a sample program. It's up on Replit. There is the URL at the top at paulaustin/if and color. And let's go ahead and look at the code. So right off the bat, of course, there's some little sneaky gremlin in our code. But the computer's good at talking to us and telling what it is. I'm going to move my little view of me over there for a second. Name error. Name turtle is not defined on line 3. And this comes from a student example today. Turtle. Where did it go? Well, we're importing turtle. What's the problem? Well, in many languages, Python included, it reads it strictly from top to bottom as it's going to prepare to do the code. In fact, the system will actually read the entire file and then start executing when it's done. But as it's reading it, much like your English teacher, if you start to refer to someone in your story, without defining who it is, it's a bit leaves your head scratching. So that's what's happening here. Because the import turtle is on line 7, it happens after we started talking about the turtle. So let's fix that little problem by doing the import before. Now you'll find as a good practice, most of your imports will be at the very top of the file. And sometimes it's important to actually get their order as well. So if I'm importing 2 or 3, maybe the second one actually needs to know about turtle for it to work. All right, let's go see if this code's going to run as it is now. Well, the blue square that's spinning around is there. That's where we left things a bit from last week. Now let's add some color to it. There's something else coming on here I don't think we've seen before in our class. It's what's this bit? What's going on here with the what's this draw? Let's see if we stop that again. I'm seeing it scroll by. Well, remember, computers do things, they repeat things, they calculate things, they make decisions. On that doing part, so far all we've seen is drawing. But there's 2 panes here. There's 2 places that drawing or output could go to. So one of them has been this drawing thing. This is what we're going to call this canvas. It's kind of like that whiteboard, chalkboard, or literally, if you're in art class, a piece of canvas. That's kind of why they call it that. And that's where the drawing happens. Well, before computers drew, they would type onto printers. They call them teletypes. It was like an old typewriter that was controlled by a computer that could actually strike the keys, and it would be called a console. And that's what we're seeing down here. And that draw, those messages we're seeing here, are coming from this statement that says print. So we could change what it is now. Suppose we want to say draw. We could say hello. Be getting friendly right off the bat. And it's going to say hello, 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 hello. That's an awful lot of times. Maybe we should make it, when we say draw a shape, you could say, I'm going to draw. I'm going to draw. Or draw a shape. So when you run your program, you can use your print statement so it can kind of talk to the side. So while it's drawing the code, it can leave little messages. Now, saying the same thing over and over again, maybe that's not so helpful. But notice that we have other variables. We have length, we have an x, and we have a y. Suppose we're going to say, let's go ahead and change something on here. And maybe we'll pass in that length. L-E-N-G-T, length, right here. Now to do this right, what we need to do here, I mistyped that there. The print lets you build sort of like a little sentence. Now, it doesn't have to be proper English for it to be a sentence, but you can construct what you want to say by listing different pieces. So we're going to put a message. We can call that a string. We'll talk more about strings later, but it's just a little piece you want to be there. It's like writing on that whiteboard, I will be on time for school 1,000 times. This would be a really simple way to do it. But we can change what it's going to print by passing in and saying what the length is. So in the string on the side here, we don't see the word length, we see a number. This is the number here, 180. Now, where'd that 180 come from? Oh, right here. When we referred to draw shape in this loop at the end, we passed in a length and we passed in a location. This was going to be the X, and this is that Y. Now, if we passed in different numbers, well, we should see different numbers come out over here. So computers do things, they repeat things, they calculate things, and they make decisions. We'll see that a lot. I'm going to do a calculate. So instead of just saying 180, I'm going to take 180 and I'm going to subtract I, but that would mean subtracting I. Well, let's see, what is I? Maybe I'm jumping ahead of myself. We'll do two things here. And since it's video, you can go back and start. Here we're actually seeing numbers in the squares getting smaller. Seeing the little loop here? It was 180, then 170, 160, 150, 140. We're letting the computer do its calculation for us. Now, say, Mr. Austin, I don't understand what this I does, what the values. I see this range 10. Maybe if I'd done some programming, it would fit. Well, we have that print statement. We're going to use print to let the computer tell us what's going on while it's doing that drawing. So in this case, we're going to print and we're going to say I is, and I'm going to complete my sentence by actually typing I. So in this example here, we have I, but it's in a string. And when it's in a string, it's not going to change. It's just like this little message. That's why we put it in quotes. Honestly, that's why you put air quotes. It's like, I want to tell you something in the quotes. We're going to leave it exactly as is. But this I is in a different context. So we're actually going to see what the computer thinks I is as it's executing this loop. Well, enough talking. Let's go ahead and run this bit here. There. Okay. The first thing it says I is 0. Well, if I is 0, I times 10 would be 0, so it'd be 180 minus 0. And so 180 minus 0 would be 180. So that means draw shape would be called with 180. And sure enough, that's what we see here. Draw shape is called with 180. See that period here. I'm going to get rid of this little period right there. Don't need that guy. All right. So we're seeing this print. Print is definitely our friend. As we've got it. Yep, we're seeing that there. Now we get a little understanding of what, when we say for, and we see this letter, the computer science term is going to be called a variable. If you're in English, you might think of these as pronouns, just like the he, she, it. In fact, you could call it it. In our class today, we actually we changed it to it just because it kind of matched the English. So I could say for it, and I could print it, and I can print it here. And it works, so long as I'm using it the same each place. If I changed it somewhere else, like I called it cat, give it a new one here, right? And I ran my code, well, I get an error. Because now I'm trying to use that pronoun, or I'm using the variable, the computer science term, but I haven't defined it. I've defined cat. So they all have to be the same. I think we could do this. So you can make the variable whatever you want to. You can name it, it's your own little pet variable, like a pet rock. Give it its name, but use it the same name every time. Think of that. When God gives you a name's a very important thing. Now you might get nicknames too. It's another special, even more important piece. The names are ones you like. Well, let's go back to I. Does it run? It runs, no errors. So we get this idea or this understanding that when we do this loop, when we say we want I to have this, to go from all the values, it's going to count up for us. It's just taking care of the work all the way for us. And if you caught it, it's a little interesting piece. We'll see this a few times here, but it actually starts off not at 1, it starts off at 0. So it goes 0, 1, well, if I count it with my fingers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I got 9 fingers? No. Computers like to do things starting with 0 in a lot of cases. So if I start from 0, I'm going to end at 9. If I started at 1, I'd end up at 10. But for computers, you're more often than not, you're going to see that it actually starts off at 0. Most common errors you'll see are Microsoft. They did lots of studies on bugs. And they had one whole category which was called the one-off error. And it was logic where someone wrote a program and it did things one too many times or one too few times, because it's just something that the programmers, or a common mistake, we're apt to make. Well, let's get to that color now, shall we? Oh yeah, here's that it. This is from our code that we did today. I'm going to go ahead and change that it right there that I had right here. I'm going to go ahead and change it back to I. Variable's named it, just kind of like, it's not a standard thing to do. But it's good to tie it into the English language. So if I is going to go for the square, the first value will be 0, 1, 2, and 3. In fact, I could do that. Print I. There, simple way. Run it. There we go. Ah, all this other stuff. It's making that print statement noisy. Here, we'll just do this. Run. There you go. There's the numbers. 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. So could we use that 0, 1, 2, and 3 to change the color? Could we say 0 is going to be, say, blue and 1's going to be red? Well, the way we could do that, so we've had computers doing things, we've had them repeating things, they're doing it really well, but we haven't made it make a choice. It's always plowed forward. It's like the railroad track with no switches. We're going to add a switch now. And the way we do that, again, very much like the language, spoken language, if. We're going to use what's called a conditional. So we're going to say if I, we're going to ask a question about it. And let's see, since it goes 0, 1, 2, and 3, I could say if I is equal to, let's see, I could say if I is, well, I'd like to say I is, but that's not the word we're going to use for the math. We're going to say if I is equal to, and computers equal to, it's not quite the same as math. We actually say the equal sign twice. This is where when we say equal to for an assign, that means sides will take on the value of 4, but when we want to compare them, it's a different kind of equal. And we only have a few characters to work with on the keyboard, so instead of using a different symbol, they just said 2 equals in a row. And it's that way for many languages. You'll see that in Java. JavaScript, there's an even weirder twist to it, but we won't go into that now. So if I was equal to, well, it starts off blue, so let's change another one. If I was equal to, say, 2, in Python, we just do that little colon, and then we're going to change the color. Now, how do we do the color? Oh, here, pen color blue. All right, we'll go green. And let's see what happens when we run this code now. Well, we got a little bit of blue. I'm going to slide the screen over just slightly. I got a green, 2 lines of blue, so that'll be the 0 and the 1. And then on line, so 0, 1, well, let's draw so you can see. So that's line 0, this is line 1, this is going to be line 2 on that big square, and turns green. And it never changes back. Well, why is that? I mean, wouldn't I see blue, like 2 lines of blue and then 2 lines of green on each square? Well, this is another one of the most common mistakes you see in programming, is to do the if, but to not think about what would happen if it wasn't that. And the way you'd say, in English, I might say, if I is equal to 2, otherwise, well, that would be the most logical thing. But we don't want to type otherwise, so it's a shorter word, else. And so here, see before the only place, it turned blue at the very beginning, but there was nowhere that turned to any other color. So now I can say here, else blue. Run this code here now. Can I get that? There we go. So line 0 and 1 are blue. The line 2 is green. And line 3 is blue again. I guess that's right, because only one of the sides is going to be green. So maybe we could do red. Well, gee, I only got 2 colors now. That is the first step. There we go. If it's 2, we'll get the green. Otherwise, this is going to be red. Well, how could I make something for each one of the colors? Well, I could say if I is equal to 2, otherwise, if I is equal to 1, otherwise if, well, Python has a nice, Python likes to keep things very short and concise. So they have a special world for saying else, if, see, I was going to say in some languages you'd see it done like this, but Python has it even shorter. It's called elif for else if. And I can put another test here. I can say else if I is equal to 3. And we'll just copy this color here. What color we'll do here? Well, we could go back to our blue. Now, I was thinking as our code here, you know, in our I just mistyped. We'd run it. We got red, green, and blue. Now, note that when we're in this drawing, by the way, we've covered every option, right? Because we've said if I is equal to 2, otherwise, else if, it's equal to 3, then otherwise, or else, make it red. So is there any value of I that wouldn't pick a color? Well, since we have an else at the end, we'll always end up, that's the default option. No, we'll always end up here unless one of the other tests work. The reason we're saying that is that means we don't need this code up here any longer. So we don't have to set it blue. There we go. This is interesting, this one line is black. We'll have to dig into that. That's kind of the very first part. We're not going to cover that in this lesson here today. So now we've got that. We've got 1 and 2. Maybe I should, well, I don't have a 1 actually. Maybe I should go and do that. So if I wanted to add another one, I'd say if I is equal to 1. Can you see a bug I'm going to have yet? You know, making bugs in your code, I'm going to say, well, actually, it sort of worked. Yeah, it does. I can see why. But that says if I is equal to 1, make it purple. If I is equal to 2, green. Where's our purple? Do we have a purple? Oh, wait. Else. Oh, yes. See? The logic isn't so obvious here. Maybe it made it purple here. But this if, and this is an if. So this bit right here, it's this line here is always going to happen inside of this. If I type this, not else there. If I type this, now the block is going to do something for 1, something for 2, something for 3, and else red. So before we were setting it to purple, but we were also setting it to red before we ever drew. Let's run with this here. There, we've got 4 colors and 4 sides. So I'd like you to play around with this. Change the colors, change some of the other stuff you've been making to make all sorts of crazy curves and twists. Well, this is a summary of what we did in class today. May you have a blessed day. Bye.